Let's dive right into one of the coolest questions hanging over AI right now.
Mm.
Can large language models, these incredible text generators, actually teach themselves to think strategically?
Yeah, it's a question that really gets at a known challenge, right?
Hmm?
LLMs, I mean, they're amazing at language, but that long-term planning, looking way ahead, that's often been a weak spot.
Oh,
They're mostly trained to predict, the next word or token. Great for making sense locally, but not necessarily for winning a complex game that needs a grand strategy.
exactly. Like they nailed the sentence, but maybe not the whole story arc.
Oh.
So this paper we're digging into, self-evolving LLM agents for strategic planning, tackles this head on. Can they learn to play that long game?
And get better at it themselves, yeah. They needed a really good test bed for this. Something complex, strategic, but, manageable for research.
And they landed on Settlers of Catan.
Classic choice. And a brilliant one, actually.
If you've played Catan, you know it's,
Yeah.
well, it's not simple.
Yeah.
What makes it such a perfect challenge for testing strategic AI?
Oh, it's got everything. You've got the dice rolls, so there's randomness. Hidden info with the development cards.
Uh-huh.
You've got multiple players competing for the same spots, the same resources, wood, brick, sheep, wheat, ore.
Resource management is key.
Totally. You're building settlements, upgrading to cities, laying down roads, maybe going for longest road or largest army, all while trying to trade, adapt, and race to 10 victory points.
And you have to react to what other players do, block them sometimes.
Exactly. It demands planning, adaptation. It's just a fantastic microcosm of real strategic challenges. Perfect for seeing if an AI can, gear it out.
Agreed. It's messy enough to be realistic. So
Yeah.
our mission today, unpack this research. Look at the different AI agent types they built.
Right, how they set them up.
See how they tested them in that Catanatron simulator against a standard bot.
The alpha beta bot, yeah.
And really discover what this means. Can LLMs evolve their own strategies, their own prompts,
Uh-huh.
even their own code?
And spoiler alert, some of the findings are genuinely surprising. It might shift how you think about LLM capabilities.
Okay, let's set that strategic stage properly. Why, again, are LLMs kind of out of the box, not Catan masters? You mentioned the local coherence thing.
Yeah, exactly. Their training optimizes for making the next part of the text make sense based on the immediate context. Winning Catan isn't about the single best move right now, necessarily.
It's about the long game.
Right. It's about a move that sets you up 5, 10 turns down the line. Anticipating resource needs, blocking opponents, that kind of global long horizon thinking isn't usually their default mode.
And Catan forces that. Getting to 10 VP requires a plan. Maybe you rush settlements early, maybe you focus on development cards. There are different paths.
And you're always juggling those 5 resources, dealing with the robber, making trade-offs. It's that blend of luck and skill that makes it such a rich test case.
Okay, and they use the Catanatron framework to run the games.
Yep. Basically an automated Catan board. Lets them run tons of games consistently for reliable data. And they needed a standard opponent.
The alpha beta bot.
Right. Think of it as a decent rule-based player. It follows a fixed strategy, doesn't learn, but plays reasonably well. A good benchmark.
Okay, so we have the Challenge Catan and the Arena Catanatron versus Alpha Beta. Now, the players, they didn't just test one type of LLM agent, right? There were 4.
4 distinct architectures, yeah. Kind of showing a progression in capability and self-improvement.
So what was the starting point? The simplest one.
That was the base agent. Super straightforward. It basically just took the raw game state information from Catanatron.
Like coordinates, resources, VP.
Yeah, all that stuff, and fed it directly to the LLM, essentially asking, okay, based on this, what's the move? It's like minimal handholding. Let's see what the raw LLM can do.
Just asks it to figure it out on the fly. Okay, what was agent number 2?
That was the structure agent. This one got a bit more help. Instead of just raw data dump, the game state was presented in a more organized, structured way.
Easier to parse, maybe.
Exactly. And critically, it used prompts that were written by humans. These prompts likely contain some basic strategic advice or heuristics.
Ah, okay. So this shows what an LLM can do with good input and some expert human guidance, but it's static. It doesn't improve on that guidance itself.
Precisely. It's a baseline for LLM performance with human help, but no self-evolution.
Got it. Base is minimal. Structured has human help. Now, how did they get the self-evolving piece in there? Agent 3.
Okay, now it gets really cool. The third one was the PromptEvolver. This wasn't just one LLM. It was a system with multiple roles. Think an evolver agent and a player agent.
Good.
The player agent plays Catan using a prompt. The Evolver agent watches those games, analyzes how well the player did, maybe figures out why it won or lost, and then tries to write a better prompt for the player to use next time. It iteratively refines the strategic instructions.
Whoa. So the AI is literally trying to coach itself by improving the advice it follows. That's clever. What was the fourth most advanced one?
That was the agent Evolver, even more complex. This one also had multiple roles: Evolver, analyzer, researcher, coder, player.
A whole team of AI agents.
Pretty much. And its goal was even bigger. It wasn't just tweaking the prompt. It was designed to try and autonomously rewrite the actual code that the player agent used to make decisions.
Rewrite its own programming.
Yeah. It started with a very basic, maybe even blank code template for playing the game. And the system tried to figure out, through trial and error and analysis, how to write better Catan playing code.
Okay, that's ambitious. One evolves the instructions, the other evolves the code itself. Wild. How do they actually run this?
Yeah.
Against the Alpha Beta bot?
Yep. Head-to-head games in Catanatron against Alpha Beta. And they use several different powerful LLMs as the underlying brain for these agents. GPT-4o, Claude 3.7, and Mistral Large latest.
Top-tier models. And how did the evaluation work? How many games did they need to see if this evolution thing was actually happening?
It was pretty intensive. For the base agent and structure agent, the static ones, they just played 10 games each to establish a performance level.
Okay.
For the PromptEvolver, it went through 10 evolution cycles. In each cycle, the Evolver analyzed games, wrote a new prompt, and that prompt was tested. After 10 cycles, they took the best prompt it had found and played 10 final games with that.
So measuring the peak performance achieved through prompt evolution.
Exactly. And the agent Evolver was similar, but with code. 10 code evolution cycles. Each cycle involved generating new code, testing it. Then they took the best performing code version after 10 cycles and ran its final 10 games.
Okay, so a rigorous process to see the results of self-improvement. What were they measuring? Just wins and losses?
Wins and losses against Alpha Beta were key, obviously, but also average victory points, like how close did they get even if they didn't win? Average turns per game.
Efficiency, yeah.
And also how they scored points. Number of settlements, cities, longest road, largest army, points from development cards. That helps understand the strategies that we're developing.
Right, you can see if they're learning, say, the value of cities versus just settlements. Okay, the big question then, did it work? Can these LLMs actually evolve their own strategy in Catan?
The short answer from the paper, yes, absolutely. The self-evolving agents showed really significant improvements compared to where they started.
Okay, that's a pretty big deal. Let's break it down. What about the PromptEvolver? How good was it at writing better instructions for itself?
This one had some standout results, particularly with the more powerful LLMs backing it. Here's a stunner. The Claude 3.7 PromptEvolver achieved a 95% improvement in average VP compared to its own base agent starting point.
95%, just by refining the prompt it used.
Incredible, right? GPT-4o also showed solid gains, about 22% improvement. Mistral Large, interestingly, didn't improve much with this method, only about 3%.
So the base model capability really matters. But that 95%, what kind of strategies were emerging in those prompts? Was it simple stuff?
No, that's what's so fascinating. The prompts generated by the stronger models, like Claude, became surprisingly sophisticated. They weren't just saying build roads. They learned to encode things like nuanced settlement placement strategies.
Like prioritizing good numbers or resource diversity.
Exactly, and dynamically shifting resource priorities based on the game state or their goals. Developing specific trading approaches, even thinking about counter strategies against the opponent.
Wow.
It was basically learning how to formulate good Catan strategy and articulate it in the prompt. And maybe just as importantly, learning what kind of prompt worked best for its own internal decision-making process.
So it's learning strategy and learning how to instruct itself effectively. That's multi-layered. Okay, now the agent evolver. The code writing one. That sounds way harder. How did it do?
It was definitely harder, and it started from a worse baseline, essentially random play code. But even so, it showed clear improvement. Claude 3.7 improved its code to perform 40% better than the random start. GPT-4o saw a 36.5% gain.
Still pretty significant jumps from random. What was the key insight there?
I think the most remarkable thing about the agent evolver was that it actually worked in terms of generating and refining functional code. Think about this. It starts with almost nothing.
Right.
And through this multi-agent system analyzing game outcomes, it figures out how to interact with the Catan Matron Simulator's API, the specific commands needed to place a settlement, roll the dice, etc., without being given any documentation.
It learned the game's programming interface by itself.
Yes, just by trying things, seeing results, and having its internal coder agent adjust the program. It learned how to control its actions in the game world programmatically and implement strategies it was discovering. That's a huge step.
That is genuinely mind-blowing, learning the game rules and the programming interface and writing, improving strategic code.
Okay, but how did they stack up in the end? Did these evolved agents actually beat the pants off the structure agent or the alpha beta bot?
Ah, that's the nuance. While they improved massively over their own starting points.
Right, the base agent or
Yeah.
random code. The agent evolver, in particular, didn't consistently outperform the structure agent, the one with good human prompts, or the tuned alpha beta bot in the final head-to-head results.
Hmm. So self-evolution is powerful, but maybe not yet better than good initial human design or optimized heuristics, at least in this setup.
It seems that way. Integrating really robust, long-term strategic consistency purely through iterative code generation is still incredibly challenging, it appears. And again, the base LLM's power was crucial. The better the underlying model, the better the self-improvement.
Okay, let's connect the dots. This is more than just making AIs better at board games, right?
Yeah.
What's the bigger picture here?
Absolutely. The big picture is about the potential nature of LLMs. This suggests they might not just be passive tools executing human instructions, they could potentially become active designers of their own approaches.
Self-improving systems.
Exactly. Systems that can refine not just what they do, but how they decide to do it, maybe even rewriting their own core logic. That has huge implications for AI development and autonomy.
Definitely opens up some doors. What limitations did the researchers point out? You mentioned the LLM dependency.
Yeah, that's a big one. Also, computational cost. Running these evolutionary loops with multiple LLM calls for analysis, coding, playing, it's very expensive.
I bet.
Generalization is another question. Okay, it works for Catan. But how well does this self-evolution approach transfer to totally different strategic problems or messy real-world scenarios? That needs more work.
And ethical considerations, too, presumably, when you talk about self-improving code-writing AI.
They did address that. They emphasized doing this in a controlled, sandboxed environment. A board game simulator is pretty low risk. They also mentioned manually reviewing the generated code and focusing on transparency. But yes, as these capabilities advance, those ethical questions become increasingly important.
Okay, so let's try to wrap this up. The core takeaway seems to be LLM agents can demonstrably evolve their own strategic smarts in a complex setting like Catan. They can do it by refining their prompts.
Getting much better at telling themselves what to do.
Yep. And maybe more surprisingly, by actually writing and rewriting their own decision-making code, learning from scratch.
For me, the truly jaw-dropping part was that Agent Evolver successfully learning the game's API and writing functional improving code without any prior documentation, just figuring out how to programmatically interact with a complex system through trial, error, and internal analysis. That capability, wow, it really does make you pause and think. If AI can become this kind of agent of change for itself in a complex game-refining strategy, rewriting its own logic, what does that imply for the future? What could that self-directed design and improvement mean for how AI tackles bigger real-world challenges? What new questions does this raise for you about where AI is heading?